All right. Well, welcome to week 14. This is day one. Pretty cool. This week's going to be the same and slightly different. I think that's kind of the trend. Essentially, what we're doing this week is we're going to build one full project. The labs are already also made out for you. So your work's going to be like the critical thinking part's going to be in your open-ended challenges that you're going to have. But what's important to know for this week is you are creating a ETL pipeline. So you're going to create an AI essentially that's an expert on something specific. In this case, it's going to be El Paso Municipal Code. After the night were the eyes of Felina. And the reason we picked that is because this is actually based on a project that I created. This is like the bootcamp version, so it's simplified. But also, by following along, you're going to run into a lot of like the pain points that I ran into. And by utilizing the same code, or excuse me, the same documents, you can troubleshoot things as they appear. So yeah, essentially that's it. It's going to be what I call a municipal AI, El Paso Municipal AI. The weeks are broken down, or the days, excuse me, are broken down pretty simply. So today we're just setting up the foundation, and it's all about extracting, right? Starting out with like a clean slate of information for our pipeline to use. And then each day you're going to actually make it a little better and better. And then you guys get to, through the challenges here, you get to figure out how you're actually going to make it better. The cool thing about the challenges this week is that you're going to take essentially all the skills you've learned and say, hey, how do I want to improve like GitHub Actions, or how do I want to improve efficiency or optimization? But the other cool thing is that the week is structured. So you also have to ensure that the changes that you're adding, the optimizations, are not going to hinder the future labs. So now you also have to work within a scope. So that should be cool. So for today, we'll get cracking on the actual lesson here. We're going to start with setup and extraction. So essentially here it says that we're creating this professional grade AI system. And this is going to know municipal code. And if you're not familiar, those are municipal code is city code. Every city has their own like laws and jurisdictions that say you can or can't do whatever. And we're getting those municipal codes specifically for El Paso, Texas. And essentially, yeah, that's kind of what we're doing today here. My question is, so far, does everyone understand the aim for the week? Also, I think I see mouths moving. All right, cool. We got some thumbs up. All right, cool. I have one question for you guys, and I will need some mouths, some audio for this one. Why would we even do this? My question would be right now, can't I just ask Chat or Gemini or whoever a municipal question and get an answer? Why would I even take the time to do this?
You could. It's funny, actually, this is my first instance of not trusting AI. I actually had AI look up some stuff for the city that I live in, the municipal codes, the ordinances, and it lied to me. It straight up just made stuff up. And afterwards, I asked it. Once I verified that it lied, I was like, "Hey, did you just lie to me?" Because I was just making stuff up to sound coherent, word for word, what the AI said. So because I didn't have some sort of RAG system or some sort of ability for it to reference the actual municipal codes, it just
Mhm.
made some stuff up that sounded good. And I'd imagine you're going to run into stuff like that if you don't set this up properly.
Yeah, if
It's
it's
not
not
going to know.
updated, I imagine as well, right?
Say again, what was the last portion?
I'm sorry, if it's not updated, right? So if you got codes that come in and they haven't updated AI yet.
Absolutely. So everyone's correct. There's hallucination, there's outdated information, there's false information, not to mention when chat whomever is pulling up information, where's it really getting it from? Sometimes you can ask it for sources, and if you ever click on those sources, a lot of times you'll see that it didn't get it from those sources. Or even sometimes you'll see that the sources are completely fake links. I ran into all of that. So yeah, whenever you're doing something that's like, we're talking about legality here, we should be able to get the right answer. And furthermore, if you took it a step further, not only could you get the right answer, have you ever read municipal code? Have you ever read any sort of legal text? It's insane. I think I'm reasonably intelligent, but you read it, you feel like an idiot because it's the most, or you feel like they're idiots, right? So essentially, what we're doing is creating something that has a source of truth. And we can also have it give us a response in a way that regular humans can understand. That's essentially what you're going to do throughout the week. So today we're going to talk about mostly getting rocking with like that actual data set, if you would. It's not data in the sense of tables and graphs, but it's the documentation. So what's really important is code reliability. You can also have like a safety net, if you would, with the CI portion you guys are already familiar with. I do want to be clear, when we talk about CI and later we'll get into GitHub Actions a little bit. Originally, when I created this, our curriculum was not so robust. So we could probably skip like, we don't have to get into the weeds because you guys are like expert on a lot of these things. But essentially here with continuous integration, if you need a reminder, it's a professional practice of frequently merging code changes into a central repo, and then a suite of automated builds and tests are run. That could be anything. An analogy is you could think of it as the pipeline as a tireless automated teammate who acts as a quality gatekeeper. Before any new code's allowed to enter the pipeline, the teammate runs a check. So we bring that up because we are going to integrate GitHub Actions, and it's going to be basic. You guys can make it as robust as you want. We are going to run a linter on it. Essentially, that would be it. You guys may have done that last week, and you probably overshot that, right? Overshot that scope. Yeah. Like I said, when I created this, you guys, that wasn't in the curriculum yet. Okay. So if you do need an overview, I know it was just last week, but right here, it'll take you to like an overview that I created. So it's in different wording if you just need a different perspective of it. Just another quick reminder, here's just some code for you to check out. We'll name it code quality check. It's going to run on push. Oh, obviously, real code, we could specify the specific branch. But here we're running a job. Essentially, what this one's going to do is it's going to check out the actual code. It needs it. It's going to set up Python, install the requirements that it needs to run, and then it's going to actually run the linter. And like I said, I know you guys probably overshot this last week, but just heads up, we'll integrate this into the lab today. Here's where it gets a little bit, this is the more new stuff. So data reliability, extracting challenge. Now, here's the thing, there's lots of different sources of truth, right? In a perfect world, as developers, the perfect source of truth is an API. Like there's a database somewhere, you could say, hey bro, I need this information, and it sends you an object. And then from there, you can just kind of like save it in your database or filter through it, whatever it is. Now, the question is, does your city have one of those? I don't know. Is probably the answer, probably not. For me, for El Paso, the city does not have one. I called them up, found out where their municipal data is stored. They don't release those APIs. So anyway, I found a PDF, long story short. So then the question is, there has to be other times where your data is not going to be readily available. You have to make it available, right? Create your own source of truth. That's what we're doing today. So here, we're going to be talking about RAG, right? A RAG system's only as good as the data you give it. There's that expression, especially with AI, garbage in, garbage out. You can make the best AI, but if your data is dog shit, it doesn't really matter. So here, RAG system is as good as the data you give it. Our AI's knowledge is trapped in a PDF in our use case. A format designed for visual representation, not data extraction. There's digital text and image text. If you can highlight it, copy it, paste it, whatever, edit, search, Control F, find it, it's more than likely digital text. What we don't consider is image text, and I say we as humans, right? Because if we see a PDF that is digital text or image text, we can read it, right? We don't have those limitations, so we normally don't try to break them down in these two groups. However, if you, once again, try to copy, paste, search for it, that's when you realize, oh shit, this is actually just scanned. This is just an image. So that's one of the problems we're going to run into today. So this is where OCR comes in. Do you guys remember what OCR is?
Optical character recognition.
Cool. Do you remember what that does?
Yeah, it uses visualization libraries to extract text from images. Not just
Yeah.
that, but primarily used for that.
Yeah, no, that's fine for our use case. It also recognizes characters optically. Not just okay. So we're going to use OCR, and then here it says to solve this. Let's see here if there's anything that you guys don't know. Since, like I said, you guys have learned a lot since we've started here. Um, let's see what this analogy is. A naive parser is like trying to read a newspaper through a narrow horizontal slit. You could read a bit from the first column, then a bit from the second, and then the sentence would just jumble together. I'll actually show you that right now. This is it. You guys remember newspapers? Any ancient people here? Okay, so back in these ancient texts, I'm going to ask for, oh, let me see if I can zoom in more. All right, anyone with really good vision, can someone read this first sentence starting at when?
When the cannonade began, the people through the Reichsbank were being bombarded, and thousands rushed
Hold
to
on,
the
let me stop you
square.
right there, my man. You said began the people, is that correct? Why did you
Yeah,
read it that way?
uh, that's how I was taught in elementary school.
Absolutely, because that's the correct way. What about a computer?
Yeah, if it was just reading left to right, it would go from separate article to separate article.
Correct. I could say, I can't read that tiny part. I'm going to go over one side. So here I could say the war ministry has sub officers surrendered. That's something I had to learn the hard way. When I originally built this project, it wasn't off of like a completed project, or I was just freeballing it. And it took me a while to realize how grotesque the responses were because I was looking at the output more than what was actually saved. And anyway, the long story short is that this project is set up with the pain point solved. But just know that this is a potential pain point that you could run into if you're not using something that's already chunked for you. So, all right, cool. We got that out the way. Demonstratable example. Let's see. In lab 1B, you're going to use unstructured. That is a library. Um, you're going to see its power in a simple example. Here, this example, I don't know why I wrote this because I was reading it today and I was like, this kind of sucks. But I left it in for you guys. Essentially, if it's a naive parser looking at municipal codes, it could say chapter 1.01 equipped with or display a red light. I mean, even just reading that, you can tell something's wrong. If it was layout aware, which is something we can get from the unstructured library, it can say chapter 1.01, code adoption, section this and that, and then actually present the sentence as it should be, which means that it read it correctly, saved it correctly. So let's see what we got here. Just heads up, you guys can utilize this. This is the documentation for unstructured. I know that it's real easy to just kind of rely on AI to say, hey, bro, give me the answers, tell me what's what. But I think there's still a fundamental use case in reading docs for libraries that you're going to utilize, because then you're going to learn how to use them and learn how to troubleshoot them. But essentially here, just the long story short for the unstructured library here, it just kind of says what you can do here in these docs, which is you can partition documents, remove unwanted content, extract content, prepare data, and chunk it. And then this is just an overview, but right here is where you would actually do it on the left side. So I would recommend, if you're looking for ways to optimize, right, like today in your challenge, you may be able to find ways to optimize just right here in this documentation by actually utilizing it to its full potential. And this is just one library. This week you're going to use a lot of stuff. So then, where are we at here? Pipeline efficiency. So we've already talked about like just extracting it. Okay, cool. So now it has words. It's like, cool, are we done? Probably not. Oh, the one thing I forgot to mention is you may already be familiar with like ETL. You may be familiar with RAG. You may be familiar with vector databases, right? Chunking data, all of that. What you're not familiar with, what you're going to run into this week, is how to do everything a little more old school, kind of. Well, really just manually. Now, whenever we've utilized, I think, any of those aspects, we're essentially just kind of asking AWS, right? That's what AWS does. It saves time at the cost of money. So it's real easy. It's good to know. It's still a high level skill, but it's real easy to say, hey, AWS, can you chunk this for me? Can you rag this? Can you return something? Can you whatever? This week, it's like literally like, cool, what are these tools where I can build this myself? So this is good because it's going to ensure you have an understanding of what's actually happening, opposed to like that magic of AWS. So anyway, so say we read it already. Now, pipeline efficiency, caching pattern. The problem is that this can be slow and repetitive. So I had mentioned to you that this week you're going to do the bootcamp version. We're going to work with a test file. The test file is only like, I don't know, a few pages. The real PDF was 2,900 pages. The way that I ingested it initially is for like the highest quality. On my computer, it took 6 to 8 hours to ingest it. On your version, even if you run the full one, I think it'll be done in like a few minutes. So it's cool because you can say, oh, wow, that's optimized. Yeah, but you're still not going to get the same level of quality on the other end, but it's still going to be really good for what we're doing. And I don't think you guys want to put 8 hours every time you run this. But speaking of which, how many times do you actually have to run it, right? That's kind of where caching comes in. So with robust OCR process, they're powerful, but they can be slow, as I just demonstrated through the 6 to 8 hour example. During development, you might run code dozens of times, which you absolutely will. Did it chunk correctly? Did it read it correctly? Did it save it correctly? Whatever it may be. And the solution is caching. Caching is a fundamental computer science concept. This is where you store results of an expensive operation, such as OCR on 2,900 pages, but you reuse it later. So analogy, if you're doing a complex math problem for homework, the first time you're actually going to go through it, do all the steps, go through that function, get your solution. Next time you need to know the answer, are you going to do it all over again? No, it's written down, right? Just go right to it. So here's we can kind of call this essentially mock code. Here we're going to create something called a cache file, and it doesn't matter what it is. It's just right now it's called democache.txt. We have a function defined here. It's a very slow process, right? You can tell by the name. Obviously, you wouldn't name it that, but for illustration purposes. And here it's saying that this slow process comparatively takes 5 seconds, and we can see that right here. It intentionally takes 5 seconds for whatever, just for this illustration. So what are we going to do? Let's check. Let's check the path. Let's check for this cache file for this specific file right here. If this file exists, well, what are we going to do? Okay, cool. Let's open it. Let's read it. Let's return it. All right. Now, what if this does not exist? If this cache file doesn't exist. All right, cool. Well, let's run this slow process. And then essentially, the slow process is going to create this file is what it is. So then the point being that you'd only have to run this slow process one time. Every time in the future you can check. If this exists, good, it's already cached. We get to skip the slow part. Now this is this seems a little silly. It's actually super important. There's a lot of times, I've worked out also before with large data sets, like numerical computations. And same thing, if you're not getting any new data, you only have to run those results once, whether it's locally or on a cloud server, and then cache it. And then from there, all your backend is doing is returning data. It's just returning small pieces of information opposed to paying for calculations each time. But you'll see this logic in our code today, but actually written out the way it's supposed to be, not just like mock. So here, I want to say that's the whole lesson, but there's one other part, which is here. It is more about to OCR of like actually what's happening. So in our project, we know that like we're going to extract text from a PDF. We already know what OCR is, at least the concept of it, but at the simplest form here, OCR is the process of converting images of typed, handwritten, or printed text into machine encoded editable text. So like we said before, it's like an image, not actually like, binary text in that sense. We'll skip this analogy. I think you guys get it. But I do think this is important too. Just a flat image, you can just think of it as one layer. I don't know if that's a different perspective. I know that helps me conceptualize things, thinking of depth. Just think of it as one flat thing, and that's that, opposed to, So Why we need it, trapped data problem. Much of the world's information is actually trapped in formats designed for human eyes, not for computers. Scanned documents, photographs of signs, PDFs. To a computer, it's just pixels. So it's the same as a cat. A picture of a cat, same as a picture of anything. It's literally just looking at the pixels, and then it's saying, what the hell kind of picture is this? That's essentially what it's doing. It just kind of accepts it for what it is. So then you can't search for specific words, copy and paste. You can't feed the text into an AI model. This one's a little misleading because you may have before said, no, I've submitted images with words to an AI, but it's actually just doing the process. It's going through the process, it's doing OCR and then returning. It doesn't magically read anything. So OCR is a bridge that unlocks trapped data. You can think of it like that, making it accessible for analytics, indexing, or in our case, serving knowledge base for a RAG application. So how does OCR work? Technical pipeline. This is cool. We're kind of just going to do like a little brief overview of like the history of OCR before we get into the project. And that's because today it's a little bit of a lighter day. It's more on you guys to enhance, but you'll have time to do that. But so OCR. So modern OCR is not one single action. It's actually a pipeline. It's a multi-stage pipeline. So here's how you can think of these steps of what's actually happening. Pre-processing, cleaning the image. The first step is to clean up the input image to make it as clear as possible for the recognition engine. This is often the most critical stage for achieving high accuracy. So de-skewing. What happens if a PDF, for example, was scanned at an angle, right? It's skewed. Binarization. The image is converted to black and white. It can remove shadows, color variations. It can make the character stand out with more contrast. Noise removal. The software removes digital noise like random specks, smudges, or artifacts from scanning. Like imagine, I don't know if you guys ever remember like old scanners, especially if you scan copies, scan a scan. Then there's a layout analysis, crucial step. The software analyzes the page to identify distinct regions, separating columns, paragraphs, headings, and images. Concept of this is what we saw with the newspaper. So the first step is it cleans the image. Then it can read it. So there's older and more modern method, and in fact, we're going to talk about even more modern, but older method. It uses techniques called matrix matching. You don't need to memorize that. The software would have stored the library of whatever character in a specific font like a stencil. It would then compare a character from the image to the stencil. So I think that's super cool, but I think you could see how inefficient that is. It's literally just saying, okay, here's an object. What does this object match? Which letter does this object match? Oh, this is an A, perhaps. The modern method. This one actually looks at the letter. If you guys are familiar with top-down and bottom-up processing, an example of this is if you saw a pyramid. Some people might just quick look, wow, look at that pyramid. I could see it. It's like this, right? Giant triangle. Oh, okay, it's brown. Oh, okay, I see that it's made up of bricks. Some people do that. Top to bottom, it's larger to smaller. Bottom to top. Someone could be like, wow, look at that brick. Oh, wow, look at these bricks. Holy shit, these bricks are shaped like a pyramid. It's two processes that we all do in our regular life. It's how we process information. We just are not aware of it. But essentially, the modern method is the bottom up. So instead of looking at the letter A as a whole object and comparing it, it's looking at segments of it. So for this, it might say, oh, wow, it's, what did I write here? It's two angled lines meeting at the top and one horizontal line in the center. Oh, that's the letter A. It's actually like recognizing a feature extraction is what it is. So after it cleans the image and then it reads, now it knows what each letter is, it'll correct mistakes. So it can do this based off of misspellings. It can also do this based off of grammar. The example I have here, I don't know if you guys can tell, Does everyone see what that word is? Can someone say what it is?
House.
OCR.
Yeah, a great job, guys. Yeah, it's exactly what it is. So obviously that's some sort of a typo, right? But there's a linguistics analysis, which is like if there's a sentence that says "I live in a house," it's going to be like, "Oh no, they meant a house," and it'll go ahead and fix that for you. There's context as well, which is just grammar and content. So that's step three. So just once again, cleans it, reads it, and then it fixes whatever mistakes it needs to. So modern error. Forget everything you just heard, guys. It's all crap. It's outdated. No, it's still relevant. But now that we have deep learning, uh, it's just like kind of one step again. It's sort of one step. So with neural networks, there's convolutional neural networks. Those are for images, and then there's transformers. So here it says these systems use complex neural networks that are trained on millions of documents. They learn to go directly from the pixels of an image to the final corrective text in one step. So the CNN is especially good with visual patterns. That's why it's used with images. And then the transformers are excellent at understanding sequence. And then there's layout-aware models, which is modern systems like layouts, layout LM, excuse me, that's one thing, that are trained not just on the text, but on the position and style of the text within a document. This allows them to inherently understand the difference between a header, a list item, a table, a paragraph, similar to what we were talking about before with like the different chunks or excuse me, paragraphs. Question, does this make sense to everyone or does it not make sense to anyone? All right, cool beans. So in terms of the lesson today, that's essentially it. This is the first step that you guys need to know to have a good foundation if you are going to create something like this. Obviously this week you are, but I just mean within your personal projects. I just want to iterate, I think especially at the level that a lot of people are here, the bootcamp level. I don't know, sometimes I think the concept of speed and output seems to have a greater weight, like, but it doesn't. I would say that foundation for any project you work on is going to be the greater weight. And if you guys do that, you essentially can't fail at anything. So, cool. So we got that rocking. Let me see what some of this is, just to make sure. Okay, cool. All right, cool. So I had this, which is, let me see if this was the first one. Okay, so yeah, so if you are going, well, excuse me, I say if. So you guys are going to do the lab. You could follow along with me. It's going to be fairly quick. This first page, though, I wrote, once again, before the rest of the curriculum was set up. So now to you guys, it's pretty basic. This could have just been like a quick step. So I already did this on my side, but I'm just going to walk you through it real quick just to make sure nobody misses it. But if you do need a example, once again, of GitHub Actions. Wait, am I back at lesson one? My apologies. I'm in the wrong folder. Labs. Here we go. Lab setup. This is the one to get started. You guys will be able to breeze through this once again, but I'm just going to walk you through this real quick just to make sure we're all on the same page. So the local project setup, make a folder. Initialize it. This is, you can also, set it up through your GUI in the GitHub, but I did it this way just so you guys can see that you can set up your repo completely through your CLI if you choose to in the future. You are going to need these folders, or excuse me, files. You are going to need a README. You're going to need a gitignore, especially a gitignore, and you're going to need a main.py. I'm threatening to say especially a main.py. You're going to need everything essentially. So when you create these in your gitignore, you're going to add all of these. Make sure you add all of these. Because what's going to happen is, depending on the PDF that you use and the output that you create, it can get very large. And then even sometimes when you're working with data sets, sometimes you can go to push to GitHub and it won't accept it. It's going to say, sorry, bro, it's too big. And then that's a whole nother thing on itself. So just, there, here's the git ignore. We're going to set a Python environment, which you guys are already familiar with, virtual environments. And then we're going to add dependencies. So on top of those actually, did we add requirements yet? No. So the first requirement you're going to add is going to be rough, RUFF. That's going to be a lint checker. I mean, if you used another one, I mean, you know, like I said, if you guys want to optimize it and you feel like one's better for a reason, I mean, I don't think it's going to kill anything. But this is the one that we're using for the project. Then GitHub repo connection. This is just how to create your repo and do your initial push through the CLI. Once again, completely optional for you guys. You can do it through the GUI. It doesn't hurt anything. And then create the CI workflow. So you are going to create a folder called GitHub and a file called, a folder called GitHub with a folder called workflows in it. And then you are going to create the ci.yaml. And in here, you're just going to put this. So it's, once again, with where you guys are at, this is super simple. But essentially, we're just going to create a lint checker here. So it's going to check out the code. It's going to set up the same version of Python that we're using, which is 3.11. It's going to install the dependencies from our requirements. And then it's going to run our linter. Before I move on, everyone's cool so far, right? I haven't like blown anyone's mind and no one's lost. Is that correct? And if you are, it's okay. Okay. So yeah, so essentially at this point, we're just getting the basics started. In your main.py, you're going to add this. This should look familiar, more or less. Here it says project setup complete. It's just so we can actually see this output when we run it. And then commit and push. So here you're actually going to push all of these other changes. I'm also assuming last week you guys checked through the GUI how to check your pipeline and actions, correct? Yeah? Okay. So then for today, just to show you the proof of this, if you'd like, before we get started, because this is the starting point. Here's actions. Here's the pipeline. So here's the Municipal AI branch, or repo, excuse me. Here we have the linter. These are all the steps that we defined. And then here, run, all checks passed. And then at the bottom, we have our, I can't, hold on. And then here we have our completed deal. Okay, so we didn't blow anyone's mind. And like I said, I knew you guys already knew this portion, which is why we're just kind of breezing through this part. But now we can get to what should be the fun part here. Let me get to this on my other screen so I can have my my reference here. Give me one moment, please. Okay. So for this, I'm trying to think if I should split screen it or not. I think you guys would be cool. Let's just kind of go over the objectives and then we'll just work off of the code block here. So essentially the objectives, you already know for the week, it's to use the municipal code from a PDF. Essentially what we're going to do more or less is we're going to clean it, clean the PDF. We're going to store or cache everything in a .text file. From there, we're going to chunk it into a vector database. Then we're going to have a RAG, take a user input and provide 3 municipal codes that are that should be the best answer. And then we're going to have AI, some sort of AI. Actually, this week we're using a llama. It's going to be a local LLM. It's going to take those answers and summarize the response back to the user. Today, we're not doing all of that. Today, we're literally just going to take the info, clean it with OCR, see it, and then save it in a text file. That's going to be the extent of today. Does that portion make sense to anyone or to everyone, I hope? Okay. Cool. Let's see what we got here. So first things first, dependencies. Let's do this. Do we already have requirements? So yeah, so if you guys are looking, we already had the requirements made, but we're going to have to add some more requirements because rough is just a linter. This week, not today, you're going to utilize LangChain. I strongly recommend that you guys, if you do want to get into like AI creation, especially like any sort of chatbots and whatever, definitely familiarize with LangChain. It's a big deal, and it's definitely good to have on your resume. It's definitely a good buzzword, especially at the bootcamp level. It's a strong skill to have. So we're going to utilize these. We're going to use unstructured, which is going to be for the OCR, and then we have this, which is going to help us with the PDF. So here, I'm going to move you guys over to the side here because you're blocking my terminal. Give me one moment. Sometimes it doesn't work. Give me one moment. All right. Let's see what I can do here. Here, I'm going to have to put you guys on a different screen so you don't get to be on YouTube. Sorry if I'm crushing anyone's Hollywood dreams here, but I want to be able to see this. Okay, cool. So now what we're going to do is actually, hold on one second. You know what I didn't do? I forgot to set up
Virtual environment?
Yeah. I always forget the syntax for it. It's one of those things I could do like a million times, and I just can't remember the syntax. I don't know why. Oh yeah, good call out.
Typo.
Who's that, Nick?
I think you typoed. Oh no, I guess it still worked.
Shouldn't work.
I see a folder made called V and V. I don't know.
Oh, okay, cool. So we all learned something, that spaces are a lie. Okay, so now that we got that, what is it? Vim, bim, bam, boom. It always reminds me of Dr. Seuss.
I have to look it up every time. I'm not gonna lie.
Yeah, I don't know why. It's not even a lot. And then I feel like, especially as engineers, we remember so much stuff, and we remember so
But
much
for that,
syntax and functions, and then yeah, it's
yeah.
like, oh, that's the deal breaker.
I had
Okay.
a supervisor once when I was working biotech. She's just like, and it just stuck with me. It's like I just ran out of RAM. I don't know. It just doesn't work. Like I like that.
Yeah, I've noticed that since I got into engineering, my memory's been worse. And then my other friend said the same thing, and I think it's because we have to remember so much stuff that our brain has to like delete other stuff. So, uh, you guys, let me know if that happens to you. Okay, so where are we at here? Oh yeah. So now that we did that, let's install these requirements. Why didn't that work? There we go. Okay, cool. So, did we not? Let me check one thing here. Oh, okay, well, I could tell you what, we already missed a step. I'm looking at the actual lab, but it's okay. It's like no big deal here. So what we are going to need is a file called ingest.py, and it'll be right here in your main. So we're going to want to, whoa, 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 whoa. Am I tripping? All right. Trust me, guys, I've coded before once in my life. Okay, so there we go. I wonder why that happened. Okay, so actually, let me just copy this in because I don't want any typos. Okay, so right now we're just setting up these basics, importing the OS, importing the time. We are going to keep track of time. And then this is for our unstructured that we already installed. So what we want to do here is define a PDF path, which, once again, I think I'm probably just going to copy and paste a lot of this. I don't want to mess this up for you guys, as I still type because I'm a man. Okay, so here we're defining a PDF path, which would be source data and then a test file. I'm wondering though, I mean, we can just create the folder, but I thought I had explicit steps for all of this. We'll find out as we go through the lab. I'll see if that step's there. If not, someone remind me to actually create this folder. Yeah. Okay. So we're going to have a path to specify that, but then we're also going to have a path to specify the cache. Because if you remember, we don't want to run the OCR process a bunch of times. And essentially what we're doing here is that right now neither of these files exist. You guys should already know this. But this file will exist, and I'll show you where to get it because we do have it in our repo. This file does not exist, but it's going to be created as a result of our code. So I'm trying to see if we should actually code all this stuff out. Let's see. So what we would do is have a function to get the OCR text. And we don't need a bunch of steps here, or a bunch of code here, but essentially the first thing you want to do is we want to check if the this path is actually exists or not. Let's see. Okay. So just based off of this, I think you guys are already familiar with the syntax, but we're going to say if this doesn't exist, if this PDF doesn't exist, because remember, this is what's triggering the OCR. So if this does not exist, we kind of just need a heads up here. So you could write something along the lines of error, and then what do we have here? File PDF does not exist. And then what you can do too, if you want to be more explicit, because it's like, who is this for at the end of the day? You can say, is it source data? Yeah. And this is like just in case if you delete the PDF. Or if it's never uploaded properly, or it has a different name or whatever. But this is just kind of like a little side note for you, because sometimes when you're in the weeds, like you just really can't remember everything. So, oh, here. And then if we don't have this file, we don't need anything else. So we're just going to return it and kill it. But unexpected indents, okay. And what about this guy? Who knows what's wrong with this? Anybody? No? I see Nick fuming here.
Hover over it.
Say again?
Oh,
Perfect
your
turn.
your def right there doesn't. It's not a proper function or not a
Yeah,
properly
you
closed
need to
function.
tab
Your
in it.
indentation's messed up.
Where?
Highlight the if statement and everything inside of it. No, if statement. Yeah, and control whatever the shortcut is on your keyboard. Bracket.
For what? Wait, you're gonna bracket it?
No. Control bracket is my shortcut to tab everything
Syntax.
over once.
Well, the method itself has a syntax error because it's missing the parentheses.
Yeah, that was
There
the
you go.
question. Yeah. Later, I do want to know what you were trying to tell me though, because I'm sure it was something that.
You did it.
Oh,
The
okay.
hot command is control closed square bracket.
Oh, weird.
Indents
Okay, on my
everything.
computer, it's just tab. Oh, I see
Yeah.
what you're saying because of, okay. Yeah, and then shift tab untabs it or tabs it left. Okay. So let's copy and paste, save a little bit of time. But here, so then what we're going to do is check for the cache. Cache check here. And with this, okay, so like we're already checking, hey, does this PDF exist? Does our starting point exist? If it does, and we get past here, well, here's saying if it doesn't exist. So if we get past that, then we're going to say, what about this OCR text, this cache? Does it already exist? So if it does, we can print a statement here that just says, hey, we found it. And we're going to load it from this actual file. So it's a verification that it exists and we can utilize it. And then we want a little bit more verification. So we also want to see, in addition to if it does or doesn't exist, we actually want to see like a sample of it, if you would. So we want the access to actually read it. But the thing is, like the meat of all this, oh, actually, we need to handle this other case. Well, no, that's fine. I guess if anything, we can call this 2A. So if the cache doesn't exist here, because since we're returning this would kill it, so at this point, if it didn't kill it, we can now run a new function here. Or not a new function, but more of the code. And then we'll skip this issue right here. But essentially what we're going to do is that no cache found. This is where like the meat starts here. Because if we have a PDF and we get past that, and the cache file does not exist and we get past that, that means now we have to do something. So here what we can do is alert us, the user, to say, hey, no cache was found. We're going to start the process by taking this PDF. And hey, it can take a few minutes. So here we don't have any logic yet. This is just about writing this to get it written. This is essentially it, in a sense. This is kind of why earlier we had showed like that very basic like ifs condition, if you would. But my question would be, at this point, does everyone understand what we're doing, what these are doing, and why? Or let me ask, does someone not understand what these three pieces are doing? Does anyone do or don't understand? Does or doesn't understand?
Pretty sure I
Troy, let
understand
me.
it.
All right, Nick, understand. What about you, Troy?
Yep, I'm here. I understand or
Okay.
don't understand.
All right, cool. Yeah, so the reason I'm asking is because like this is basic, but this is like the this is at least one proper setup of saying like you know what I mean? Like it's like we have a system that is a logical flow. And if we don't set it up, we're either going to not have this optimized system where we're like just OCRing the PDF for every question we have, right? Like, oh, is there a fine for littering? Imagine waiting like 20 minutes. Oh, it has to go through the whole, the whole rigmarole. So anyway, that's essentially what we're doing here. Okay, so now that we have this, we don't actually have a PDF. So we need a PDF in here. If you guys remember, we do need a source data folder. So let's do that real quick. Am I tripping? Yeah. Okay, so here we have source data. If you guys check in week 14 resources, there are going to be two different PDFs. One is going to say test file. If you look at it in here, it looks like nonsense, but don't worry about it because you don't have to read it. Just know that as long as it's in here, you can see it. And if you actually want to see a preview of it for week 14, in the resource file in GitHub, you can see it, or if you download it, you can see it. It's just within this, it's not going to show you it. Okay, so now that we got that, here's what we're gonna do. Let's try this real quick. All right, so we added our source data to our gitignore because we don't want to upload that PDF. Let me see what else this thing says real quick. Let me see what happened here. No module I'm not sure. Okay, so right now I was just going to run this just so we can see the output, but it is showing that unstructured's not there. Does anyone know why? I mean, I have one really good guess. Does anyone know why? Or have a really good guess?
Let me. So what from instruct is it not in your requirements or like what had you imported it yet?
That's a great first question.
Maybe okay.
Have you installed it?
Yeah.
Yeah, had you like done it? Well,
Did it?
So yeah, so good question. So
from a
it is
PDF,
in
so
here, and if you look earlier here,
Yeah. Typo.
yeah. And
Yeah.
I knew something was wrong because when I typed it, nothing happened, but no one said anything, and I said, let's wait and we'll talk about this later. So you guys, you know, could be aware of it without me directly saying it. Okay, so now it's installing. So now that it's installing, um, I don't remember it taking this long, but it's okay. So now that it's installing, we can run it and then see what happens. Does everyone think this is going to run?
Yeah. It's going to take a while to install.
Is it? How long does it take? Did you?
Mine's been running for quite a bit. It's installing Torch, which is almost a gig.
Let me take a look here.
And then I guess
All right, class
the actual
dismissed.
question is
No, just
it
kidding.
going to run?
Yeah, the next question, is it going to run?
I got a minute left on install. No idea.
Anyone else have a guess?
Path.
But when are you actually using unstructured in the lab file?
When are we using it?
Yeah.
Good question. Right now, we are not.
Oh, so you're literally just what encoding UTF-8 and extracting the text.
Right now?
Yeah.
Yeah. Yep. Right now, we're just setting it up and just seeing if it works. With this whole lab, it's set up how you would code. The other labs that you guys have been doing, my concern with it is because obviously you guys are learning, but it's set up to me like it's set up as a finished product, and you're getting chunks of that finished product. And then what's happening is you're just kind of like copying over these completed chunks, and you're saying, cool, it works, I can code. But whenever you code, it's not a printer, right? You're not like printing top to bottom and hey, I wrote 100 lines of code. Um, you're writing pieces, you're writing fragments, and you're testing along the way. That's how you actually code, especially pre-AI. You know, or even if you're using AI, you should have it do the same thing. You should really break things down. So in this case, it's like this is it. This is coding. This is the first step. Is like, can we actually get this PDF to even show up? Can we get this thing to even recognize the PDF exists? Can we see these proper errors? Um, so to answer your question, you're absolutely right. As of right now, we're not using this. We just imported it because we are going to use it. And it's kind of like a little reminder, yeah, let's import this. But we're going to utilize it in the next step here. But for right now, now that the install went through, let's see what happens if we run this ingest. Shouldn't take this long, so something's already wrong. Anyone have any guesses?
I mean, does the path exist?
Which path?
Like, so source data. So, I mean, because it's slash test file. Is it in the right spot? I don't see it. Yeah. Source data. Yeah, it looks like it.
Oops, sorry. Yep, so we do have
You
source
got an error
data.
down there.
Say again?
It spit out an error down there. Path exists.
So let's see what we got here. So trace back, get OCR text, obviously is this.
Looks like
OS.
it's a package. So Is dot path exist, so os dot path exist, did you import or, well, I mean, I assume you have pip installed. Was OS in your package? In your requirement?
It's you need a period between path and exists on line 11.
What path dot exist? Oh yeah, it's down there at 18.
Okay, so
then
then what happens?
OCT. Typo, OCT versus OCR. It
Say
looks
again?
like
Oh, which line are you looking
OCR.
at?
It says line 18, OCR text cache. Oh yeah, line 7, OCT. It needs to be
Uh-huh.
OCR, I think.
So you may have noticed. Exactly. The answer was there the whole time in yellow. Welcome to this week, at least today. Like I said, it's one thing when these labs are already created, but it's another thing. This is mimics more of the natural process. We have typos. We don't import correctly sometimes, or if we have more typos.
Can I see your requirements.txt
Yeah, absolutely.
really quick?
What are you
Thank
looking
you.
for here? Are you
Trying to
just
figure out why
asking?
my pip install is still running. It's installing a ton of stuff.
And it was
And mine
prior
only looks.
to me running it?
Oh yeah, I started it way before you.
What kind of computer are you using?
It's a Windows PC,
Yep,
Core
there you go.
i5.
I'm just kidding. So you have an i5?
Yeah, it's got an i5. So it's not that slow. It's downloading a bunch of really big packages, so the difference between my requirements.txt and yours is I also have PyMu PDF at the very end. That's the only difference.
No, I'm just kidding. Yeah, that
Did you
shouldn't.
leave that out of yours on purpose?
No, I didn't leave it out on purpose. That's actually a good question why it's not in here. But yeah, actually, let's see if we need it then. Okay. Or if it's a later, I may have separated it from.
Yeah.
I made
I
this
just wanted
4
to
months
see.
ago. But let's find out here. So we did update that typo, correct? There's no errors or anything in here. So now let's run it. All right, so what is this? Is this good or bad?
That looks like it worked. No cache. Oh, wait, no cache found. Starting OCR process. That looks right to me.
Yeah, everyone's
Tell me I'm wrong.
comfortable with this? Is anyone not comfortable with it? Or everyone thinks we should move on?
It says it retrieve text verse 200
Mhm.
right there. So that's on the bottom. Yeah.
Suppose I'm comfortable, but that OCT text cache is probably killing me. But in blue on line 20.
Line 20, this?
He changed them all to OCT, so it works.
So it works. It's just killing me. Yeah.
What's because it says OCT instead of OCR?
Yeah.
Okay, good job. So check this out. Oh, what the hell? Good catch. I don't know if no one else cared or no one else noticed.
I mean, I
assumed
was
you did it
wondering
for a
why
reason.
I was wondering why you like corrected it that way instead of, because you've been calling it OCR as like the actual term.
Yeah.
So I was wondering why because in theory it could be, it's just a variable, so it could be called either, but I was wondering why you corrected it the opposite the way I would.
Yeah. Like I said, I'm just curious if you guys are just copying or if you're paying attention. And it seems like you guys are paying attention. So solid. Okay, so OCR. Right now, we got it to the point where it's checking and it's saying no cache is found. And we know this is true because we don't have any cache, right? Our cache is defined as full text OCR.text, which does not exist because we don't have anything that would even create this yet. So here's the cool thing, right? So what we're going to do now is create a variable called start time. If you remember, we did import time up top. So let's do time the function, right? One's just calling it, one's actually declaring or calling the specific function. Then this portion I'm going to copy in, but actually, real quick, if you're going to have a start time, make sure you have a, good job, guys, end time, right? All right, this portion we're going to copy in. Essentially, the start time and end time is just going to say when we run this OCR process, we do want to keep track of the start time, keep track of the end time. That's because like examples like the original version of this, that's like I said, took 6 to 8 hours. It's just good to know, especially if you're going to walk away, come back and run it a bunch of times. All right, we have something here called elements. Partition the PDF. The file name is going to be the PDF path, so we're not changing the file name. Strategy, high res, powerful, right? What a great comment there. And then the table structure is true. We wanted to infer table structure. That's because our PDF does have tables and sections. And then the model is YOLOX. Question, who knows what this is and where did I get any of this from? Don't say from the lab. Like, where did I get this from? What is this?
You got it from documentation, right?
That's the answer. Documentation. There's no one in the universe, unless you're working with this specific library, would possibly know what the hell this is or where it came from or how to write it. So if we go here, this is part of the documentation. And specifically, it shows us here available options for strategy. So I chose the one that was high res. Essentially is what it is. They have different use cases. You guys can read this, when it's convenient. So this is an OCR strategy. This is the one that I chose to utilize for this specific PDF based off of my understanding of its complexity. So the thing is, it's going to do this whole OCR thing, right? The magic. Then what? Okay, well, then I'm going to create a variable called full text. It's going to join it. So new lines join string for each L, you call it whatever you want, but here it's just each element in elements essentially is going to construct this full text here. What I want to do is once this is actually done running, here we're going to create a new line, right? OCR process finished in how long? Just end time versus start time. And then we want that in seconds. But let's add this one other thing right here. Not implemented. Text. Here we go. So this we don't need anymore. Where does this with go? I'm back here. Okay, cool. So anyway, start time, run the whole OCR process. We want the full text here, which we're going to use in a moment. We want to know the end time when it's done. Then print, OCR process finished in how long? Okay, that's always good to know. But here it says saving OCR text cache file. This is a specific file, the same one we specified up top. Question, what's going to happen now when I run?
It should write that cache file.
Anyone disagree?
Oh no. Hold on. Get OCR text. I think it's going to work.
Okay. Cool. So the one thing I am going to do though is I'm wondering if we could replace this whole thing if we don't need it. Here's what I'm going to do. We'll just swap that out. So the other one before was like our cool output for what we needed at the time. Now our process changed, right? We already added a new step. So now we just want different information. So let's run this bad boy, see what happens. Okay, cool. So no cache found, which is true. We don't have cache. Retrieve text, first 200 characters. OCR not implemented yet. Wait, why does it still have that? Oh, is that from before?
Yeah, that's the previous run.
Okay. So here, no cache found. True. Starting OCR process. That's what we want. It may take a few minutes. Cool. Warning, no language specified. Defaulting to English? Good. It doesn't matter for our use case. The max size parameter is deprecated and will be removed. Okay, that's just a warning. We'll skip that. OCR process finished in 12 seconds. Cool. Saving OCR text to cache file. Here's the file name. Here's the actual file. Verification successfully retrieved 9,618 characters. Here's what we requested. Look, so chapter 12, equipped with or displayed red light, yada, yada, yada. So real quick, let's go to full text OCR. So we can see that this aligns. So it did create the file. It is returning the first, 200 characters or whatever we specified. Looking at this, what are you guys thinking? Is it right? Is it wrong?
It goes with the flashing.
Jumbled.
Jumbled? What's jumbled? Don't talk about my code. I'm just kidding. So what's jumbled about this?
Aren't those partial sentences? And then you've got like two line breaks where your cursor is. Limited purpose of this subsection of the subsection dot such city double space B dot, right? Isn't that all?
What was it? Right here? Such
Yeah, that's all.
city, B, the
Yeah,
driver of it. It could be.
doesn't sound like real sentences.
Sure, so safety of it, all other persons, nor shall such by dash, and then 12 that. So you think it's jumbled, we messed up. So now what?
Well, I was curious before on your join statement
Okay.
where your join statement logic was coming from, because it's rather arbitrary unless someone told us that we're joining on new line, maybe.
Oh, I see what you're saying. Are you saying are you saying it as a comment of you think we can get rid of it, or you're just saying it as a comment of like, how the hell would you know?
Yes. How the
Okay.
hell would you know? Yeah.
Good question. I'll tell you when I made this, there's a lot of trial and error. It's a very real old school. Just figuring it out. And that's why I tried to mimic a lot of even though this is a simplified version, I tried to mimic a lot of the same pain points that I went through to just kind of give you that like realism of how you're developing, not this magic where, oh, you're a developer, you create something the first time and it's perfect and you write it like a printer does it. It's just not how it works. The one thing I do want to show you guys, let's see if I can get this, week 14 resources and test file. So just so you guys can see this real quick, because we are running out of time here.
Is
And I
it
also don't want to bore you guys. But yeah, this is it. This is the test file. So yeah, see, like we can't even, you guys should already know this, we can't even search because it's an image. But where was that one thing we were looking at? Adherence to regulations. Anyone see that anywhere? Yeah, here we go. Adherence to
Yeah,
regulations.
no, it's the thing that you said, what was it called? It's reading just purely left to right. It's
Yeah.
not sectioning off. Because yeah, it starts with equipped with or display,
Mhm.
which is the uppermost right-hand column, which shouldn't be that high in the file. Yep.
Okay. Yeah. Okay, so then now what do we do?
We need
Because
to
we can all give up.
implement that I forget what the term for it is. Sectioning?
Okay, but like how?
You have to
Like
look it up in
because this is the
documentation.
code. I mean, we only have 50 lines of code here. What can we change in this 50 lines to make this work?
I would go to the documentation for the libraries we're using and try to see where you set that sectioning.
Yeah,
Is there
which might
something?
go in the elements portion there. So
Yeah, I would have to see if there's any different settings.
Cool. Like what?
Yeah, it says infer table structure equals true. Strategy high res model. I don't
I
know.
don't
I
think that,
assume that there's some
yeah.
settings you could tell it, hey, it's actually 2 columns
Okay.
or something similar to that. Maybe not that simple, but
So the one thing we can do, you guys are definitely on the right track, and that was the answer I wanted to hear. No one here can know that answer, right? It doesn't, like I said, it doesn't work like that, and that's the whole point. But what I was hoping is that you would say is, oh, we have to check the documentation, and that's exactly what you have to do. But I don't expect you to know now by magic. But right here, if you check out the PDF, you notice it's in 2 columns, which we've decided. The problem here is high res we're using. It's powerful. Oh, my bad. It's powerful for detecting different types of elements, titles, paragraphs, lists, but on a 2 column layout, it can get the wrong order. It's too smart for its own good. I don't know if that's true, but it's like that one FIFA ball that was so perfectly aerodynamic that no one could kick it where they wanted to. I don't know if you guys know about that. It's a real thing. So
Yeah, it got canceled or something. It
yeah,
got canceled
it's crazy.
a
But
lot.
but mathematically it was. It was the most perfectly created ball. Even the pros couldn't even hit it. All right. So here's what we have to do. We just have to change this to this. If you guys had looked in the documentation, I had gave you a little hint. Well, not a hint, but like a preview before. But we're going to just switch to this fast method. So the high res here, it identifies the layout using the Tectron 2, right? But here, the fast will leverage traditional NLP extraction techniques to quickly pull the elements. So if this one's too smart, this one should be a little dumber. It's, it's essentially really what this is. So we're running out of time here, so let me just do this for you guys. Now, what happens if I run it again?
it's going to hit the cache unless you delete the cache data.
Perfect. Did everyone else know that, or does everyone know why we have to delete the cache?
You
Don't
put the
lie to me.
statement in there.
You what?
Yeah, you put that check.
Exactly, because we coded it. That's how it should work, because we're coding for the happy path. And it's a lot easier to just delete a text file and rerun it than I mean, there's other ways to implement it, but that's how I chose to implement it. And that way too, I figured as you guys are getting hands-on deleting stuff and adding stuff back, it's just good to ensure you know it. Okay, now what?
Do we make the changes to the code like it suggested?
Oh yeah, I did. I made the code changes, I ran it, and I'm showing the full text OCR. I'm showing the new cache.
Oh, that was fast.
Yeah, yeah. Well, you thought they were lying? They said it's called fast. It's not the high res one. But yeah, you guys can see the difference, yeah? That's crazy, huh? All right. When I was learning this, I was by myself. And, it sucks not having anyone to tell. Like, oh my God, all I had to do was change this. You know,
You
uh,
have all of us, so now enjoy
yeah,
that.
my children. Actually, it's pretty wild too. Even though I looked at the cache, I didn't realize that it was like messed up because I had just started learning about vectors. So I was like, oh, okay, this is how it looks because it helps it chunk it to put it in I just thought it was like part of the process, which it's not. It's absolutely not. Okay, cool. So we did that. We got 9 minutes. Let's see here. So add ingest pi requirements. What's this say? I'm just looking at the success criteria because that's essentially it for this lab here. But let me see here. Script runs without errors on first attempt. Yeah, creates that. Runs almost instantly. And like you said, it's fast, right? It's almost instant. You have a reliable text file that can be used as the input, and then commit your final work. I don't have to do that. I mean, I'll do it, but you guys don't need to see that. Today, conceptually, it's crazy, huh? Because I feel like this is like super cool. I don't know if you guys agree, but I mean, it's conceptually simple, but even so far, it's way more work than using like AWS. I don't think that's a bad thing always, especially as you guys are going to want to like build your own projects for portfolios. There's no reason you guys need to be spending all this money with AWS for something that no one's ever going to see. And I don't, maybe one hiring manager will, but it's like, you don't need to spend all that money. Anything AWS can do, you guys can create for free on your local scale. Um, Anyone have any questions about the topics or the labs before I reiterate the challenge and set you guys free for a while?
Was anyone able to keep up with the lab on their own machine?
I'm running it, but it's may take a few minutes. I think I keep getting sample OCR not implemented yet. So I think I might have messed up somewhere along the way.
I will say, if you do follow the lab, you guys should be cool. Like if you're copying and pasting, reducing human error, should be cool. But
For
if
the
you guys,
elements,
I'm sorry.
I was just for the elements, the two that are left, like the edited version, was it just file name and strategy fast equals fast?
For the updated, let me pull this
Yeah,
up
like after the fix to make it go
sorry.
faster.
right here. Yeah, literally, it's just file name and strategy equals fast.
And it's in parentheses. Okay. Well,
Mhm.
hopefully-
And then everything else was the same. So,
Yeah, I don't know what's going on with mine then. Oh,
well, I'll set you guys free and you guys can troubleshoot it. Definitely work in groups. Where are you guys? Here you are. Let me stop recording for a moment.